CST 239. This is milestone 4. So this week we were tasked with updating our inventory manager UML class diagram to support the following features. Initializing of a store inventory from an external JSON file using a file service. Okay. Proper exception handling for all file I/O and JSON serialization. Deserialization as well. Okay, so we were to update our flowchart in UML, which I did submit, so I'm not going to go over that. I just want to go over code here. So let's go ahead and start with the inventory manager, since that was the main class that was having an implementation in it. So not anything outside the scope of what we've covered before has changed, but I did add a new method that was invited into this class so that we could utilize the external file service, in this case a JSON, to load our inventory instead of having to hard code in objects that we could then use methods within the other particular classes for us to add an inventory to the storefront. So if we go ahead and start, we have our public void method load inventory from JSON here. It's going to go ahead and take a string of a file name. Okay, so we create an instance of the object mapper class from the Jackson library that we loaded the jar files for. Create a try box here. I'm going to go ahead and create a file object with the provided file name and path. Check if the file exists. If not, throw the file not found exception with a descriptive error message. So if does not exist. Okay. Create an input stream. Deserialize the JSON data from the input stream into an array of soluble product objects. We're using the object mapper's read value method, and then we loop through each soluble object in the array and add it to the inventory with its quantity using the add inventory method. So this is our for loop utilizing that array. So we parse through, and we're using our add inventory on the soluble product and getting a quantity. Those key map pairings right there. So those key value pairings are what are represented and coded into our JSON files. So this is why it's structured as so. Then we have a catch box to also handle some of the exceptions that may be thrown, and print from the stack trace so that we can go ahead and debug if there is an exception that is thrown. Still have our methods that were originally coded into our class. So our add inventory, remove inventory, get inventory quantity, and a map the soluble products, so we can call and get inventory and return said inventory object. Okay, so the other thing that we had to do that was a decent errorless troubleshooting for me, aside from the fact that it took me a minute to work through not necessarily having too many issues with loading the jar files, but getting the actual server to stay on long enough for me to download all of the files needed. I got through the core, and then for some reason there was multiple hours I just sat there trying to get the data bind and annotation file, but eventually was successful. Saw that there was a post from you on how to do this, but managed to see some things on YouTube and such, but watched your video, and also highly helpful as well. But annotation is important because this is going to help not only our end, but the machine end understand how this file is going to be serialized and deserialized into these objects that are utilized as inventory. So this set of annotations helps Jackson, a popular Java library for working with JSON data, to serialize and deserialize objects that belong to different subclasses of a common parent class. In the first annotation, the @JSON type info specifies that the type information should be included in the JSON data for serialization and deserialization purposes. It has 3 parameters: use, include, property. All right, so specifies the mechanisms for including type information. In this case, it's set to JSON type information.id.net, which means that the type information is included as a field in the JSON object with a specific name. Include specifies where the type information should be included in the JSON object. In this case, it's set to JSON type info .as.property, which means that the type information should be included as a property of the JSON object. Property specifies the name of the field that should be used to include the type information of the JSON object. In this case, it's set to type. The second annotation, JSON subtype, specifies that the concrete subclasses of the parent class that should be included in the JSON data. It has one parameter, value. Specifies an array of @JSON subtypes .type annotations, each of which specifies a concrete subclass and its corresponding type name. In this case, there are 3. So, first annotation, the @JSON type info use equals JSON type info.id.name. So this is the call out, which means that the type information is included as a field in the JSON object with a specified name. And we also have the include equals JSON type info.as.property and set the property equal to type. So this is going to go ahead and specify the name of the field that should be used and includes the type information in that JSON object. In this case, it's set to type in order for it to understand that's going to dissociate between weapon, armor, and health. All right. For our subclasses, so and none of the other methods within this particular soluble product class changed. We just had to add those annotations in order for us to serialize and deserialize this particular class as an object that we were coding into a JSON file with a particular format. I didn't have to change anything in our subclasses. They all stayed the same. This is our JSON file in a text file added into the actual IDE environment, but I wrote it in Notepad and eventually saved it to a folder within the same directory as the source folder. So let's go ahead and run this guy so we can see how it properly functions. So he loads in and voila. Welcome to the tavern. Please enter the ID of the product you'd like to purchase. So I added in a decent amount of weapons last time so we could go ahead and use the comparative method so that we could organize them based on name. That being said, we don't need to go through a crazy amount of purchasing, so I'll just go ahead and add a few things just to show you everything's functioning. And as you can see, you can't see because the video quality sucks, but if you look closely, once you're running the code, you'll see that the quantities are updating themselves. So we can go ahead, 0, tab out, and get our quantity total of what we've purchased, as well as a total in bronze pennies of what we owe. So thank you very much. This is milestone 4, and holy cow, I actually hit my time parameter for once. Thank you.